Good afternoon, mathematicians, and welcome to Miss Scranton's math class. In this video, we will be discussing the greatest common factor, also known as the GCF. Our objective for this video. After this video, I will be able to find the greatest common factor, GCF, of a set of integer terms. Let's get started with an example. Example number 1. Determine the GCF of 3 and 15. Now, when we find the greatest common factor, our goal is to break down every number or every term that we see into its most basic components. Most basic, in this case, means its prime factorization, so that the only factors that we are left with are prime numbers. Let's see what that means. I am going to create a tree with 3 and with 15. And I'm going to go ahead and separate them with a line here. So we have 3 and 15. For 3, let's create these branches. What are the factors of 3? What two numbers can we multiply together to give us 3? All I can think of are 3 times 1. And when you get to this stage where you have some number times 1, you can go no further with that. That means you have found a number's prime factorization. So I will underline all prime numbers in yellow. Let's do the same thing for 15. What numbers can we multiply to give us 15? I can think of 15 times 1, or 1 times 15, and I can think of 3 times 5, or 5 times 3. Which one of these two groups will probably help us a little bit more in this case? Which of the two groups, will we have to do the least amount of work for? Probably the second one. So let's write 3 times 5, or 5 times 3. If we had written 15 times 1, or 1 times 15, we would still have to break that down even further. Okay, so now, what are the factors of 3 times 1? Well, as we saw over here, the factors of 3 times 1, the factors of 3 are 3 and 1, and that is it. So therefore, we have found the prime factorization. So I will underline those in yellow. How about 5? What are the factors of 5? 5 times 1, or 1 times 5, and that's it. So again, I will underline these in yellow. So, let's start a blank page here. I'm going to write the numbers 3 and 15 using only the prime factorization that we found on the previous page. So let's look at 3 first. The prime factors of 3 are 3 and 1. So on the next page, I'm going to write 3 times 1. And that's it. Let's do the same thing for 15. The prime factors of 15 are 3 times 1 times 5 times 1. So I will write all 4 of those numbers on the next page. 3 times 1 times 5 times 1. Now, to find the greatest common factor, we need to look for any numbers that are in common to both of these lists. Do you see any numbers that are in common? Good. I see a 3 here and a 3 here. Anything else? 1 here and 1 here. So now how do we find the greatest common factor? Well, the greatest common factor is just going to be the product of those two numbers that we found. So the GCF of 3 and 15, and this is the notation, is going to equal the product of those two numbers. Now in this group here, the number that was in common was 3. You don't write it twice. It's a pair of numbers, and the number that is in common within that pair is 3. And then you multiply that by anything else in common. Here's a pair of numbers. What is the number in common? It's 1. So 3 times 1 equals 3. Therefore, 3 is the GCF of 3 and 15. In other words, 3 is the biggest number that goes into both 3 and 15. Let's do another example. This time, let's determine the GCF of 12 and 18. Again, I'm going to use the tree method. So I will draw my line of separation. I'll write my 12 here and my 18 here. All right, let's start with 12. What are some factors of 12? I can think of 6 times 2, 4 times 3, 12 times 1, although I probably won't want to use the last one because I'll just have to do one more step. So it actually turns out that it doesn't matter which of these groups you choose. Your prime factorization will be the same no matter what. So I'm just going to choose 6 and 2. Or 2 and 6. That order does not matter either. So 6 times 2. Now, let's see, can we break down 6 any further? Yes, the factors of 6 are 6 and 1, and 3 and 2. I'll save myself a step by not choosing the one that has that number in it. I'm going to use this group, 3 times 2, or 2 times 3. Now looking at the 3, what are the factors of 3? 3 times 1. Okay, we found this times 1, so we know we have our prime factorization. Oops, sorry about that. Try to underline these numbers in yellow. Okay, how about factors of 2? I can think of 2 times 1, and that's it. So here's that times 1, so we found our prime factorization. And really we don't need to do the same thing for this 2, but just to hammer in this understanding, we see that 2 is a prime number once again. Okay, moving on to 18. Factors of 18, I can think of 6 times 3, 9 times 2, 18 times 1, although I probably don't want to use that one. So again, it does not matter which one of these you choose, your prime factorization will be the same. So this time I'll do 9 times 2, or of course you can also do 2 times 9. Okay, factors of 9, I can think of 9 times 1 and 3 times 3. I don't really want to use the one with 9 in it, so I'll use 3 times 3. And as before, we've seen that 3 is a prime number. Over here we saw that 3 is prime. So we could go through the prime factorization 3 times 1, but as you get more used to this, you will start to learn and remember which numbers are prime and which are not prime, which are also known as composite. So 3 is prime in both cases. And 2, we saw over here that 2 is also prime. So I'm just going to underline the 2. Now, let's look at 12 and 18 in their prime factorizations. So we have 12 and we have 18. Okay, on the previous page, what was our prime factorization of 12? I see 3 times 1 times 2 times 1 times 2 times 1. Notice all of those times 1s. We really don't have to include those more than one time. So I'm going to write 3 times 2 times 2, and then at the end I'll include times 1 just one time. It gets pretty repetitive otherwise. And just let's double check. 3 times 2, that is 6, and 6 times 2 is 12, and 12 times 1 is still 12. So we have the correct prime factorization. Let's do the same for 18. We have a 3 times 3 times 2. 3 times 3 times 2, and even though there was not a times 1 that we saw in that problem, we do know that 1 is a factor of everything, so we'll put times 1 at the end. So now for the GCF of 12 and 18, remember we're looking for the product of everything in common. So I see a 3, I see a 2, and I do see a 1. And that's it. So in this group, the number in common is 3. In this group, the number in common is 2. And in this group, the number in common is 1. And the product of 3 times 2 times 1 is 6. So 6 is the GCF of 12 and 18. There will be a part 2 of this video where we do 2 more examples, so stay tuned for that.